Equivalent fractions. So this is one of the topics wherein students face difficulties in understanding how can two fractions whose numerator and denominator both are different, they can be equal. So we'll see some real life example to understand what does equivalent fraction mean. And as usual, we are going to solve some questions towards the end of this topic. Okay. So to understand what equivalent fraction means, imagine the scenario that you bought a pizza. And then what you're trying to do is you have three scenarios. We'll discuss each of the scenarios one by one. So the first scenario, you cut this pizza into two slices. Okay, the slices are equal. And then you have one of these slices. So if I want to represent the amount of slice that you have, or the fraction of the slice that you have in this pizza. So first of all, you write the denominator, which is 2 because you are dividing it into two equal slices. The numerator is 1 because you only ate one of the slice. Okay? So it would be the fraction. If I want to represent the fraction of the slice that you ate, it will be 1 upon 2. Right, now imagine this second scenario. Instead of cutting it into two pieces, you divide it into 4 equal pieces. Right, and out of that 4 piece, you have 2 of the slices. Now if I have to represent this as a fraction, it will be the denominator is 4 because I'm dividing this into 4 equal parts, and the numerator is 2 because I'm only having 2 parts. Right, so 2 out of 4. Another scenario is when instead of cutting it into 4 slices, I'm cutting it into 8 equal slices. Right, now when I'm cutting it into 8 equal slices, I'm just having 4 slices. Okay, so now I'm having 4 out of that 8 slice. So if I have to represent that as a fraction, denominator is 8, number of equal parts, 4 is the number of parts that I eat. Okay, now if you compare the amount of pizza that I ate in all these 3 slices, okay, you'll notice that the amount of pizza that I ate remains the same. However, if you notice the numerator and denominator in each of these fractions, you'll see that they are different. Okay, so this is what we mean by equivalent fraction. Although they may look different, they are representing the same quantity. So this represents half of this. This represents 2 upon 4. This represents 4 upon 8. So essentially what we are doing is we are just trying to divide this into more equal parts. Right, so equivalent fractions are different fractions that represent the same amount. Why are they different fractions? Because the numerator and denominator are different. And why they represent the same amount? Through this example, we saw that the amount of pizza that I ate is not changing. It remained the same although the fraction changed. Okay, so how do we represent equivalent fraction? For example, 1 upon 2 is equal to 2 upon 4 is equal to 4 upon 8. Right, so we call them as equivalent fraction because they are essentially representing the same value. Okay, again there's a note, different fractions can represent the same amount and we call them as equivalent fractions. So this is the definition of an equivalent fraction, that it is a two or more fraction that have different value but they represent the same amount. Okay, another example, if you consider this shaded figure, right? So if you consider this shaded figure, it is 1 out of 3 of the figure is shaded. Now instead of dividing the circle into 3 equal parts, I divide this into 6 equal parts, say like this. Right, now the fraction changed because the number of equal parts changed. So it is 6 equal parts, and then now instead of 1 part that was shaded, we now have 2 parts that are shaded. So it is the same thing that we have mentioned here. Right, so 2 out of 6 parts are shaded, but they both mean the same thing. Right, so they both represent the same amount. So that is why they are known as equivalent fraction. How do we find equivalent fraction? To find equivalent fraction, we can either multiply or divide. When we are doing any operation on numerator and denominator, basically multiply or divide, we should do it on the numerator as well as on the denominator, because if we just do it in the numerator, then the value of the fraction will change. So when we are multiplying the numerator with some number, we also should multiply the denominator with some number. Okay, to ensure that it represents the same amount. Otherwise, the it will no longer be equivalent. Okay, so here we have an example wherein we are multiplying a number or a fraction to get an equivalent fraction. So to find equivalent fraction, multiply or divide both the numerator and denominator by the same number. So if I have 1 upon 3, I need to find an equivalent fraction. I'll multiply this with 2, the numerator, and I'll also multiply the denominator with 2. So I'll get 1 times 2 is 2 and 3 times 2 is 6. Right, so I'll say that 1 upon 3 and 2 upon 6 both are equivalent fractions. There's one more way to find equivalent fraction. One was multiply, that we just saw. The other way is to divide. Okay, how do we divide? So if I find something common between these two numbers, say for example I have 6 and I have 8. I know that 6 is divisible by 2 and 8 is also divisible by 2. So what I'll do, I'll divide both of them by 2. Okay, so if I divide 6 by 2, I'll get 3 as the quotient. If I divide 8 by 2, I'll get 4 as the quotient. So this turns out to be 3 upon 4. Note that multiply we can do with any number, but divide we will only be able to do if these two numbers have something in common, right? Some factor in common. Okay, so since in this example both of them had 2 as a common factor, that is why we divided both of them with 2. In the previous example, we had 1 upon 3. So we will not be able to find any fraction by dividing both of them with some number because they don't have any common factor other than 1. And if I divide both of them with 1, it will result in the same fraction. Right? So it makes no sense. So division we can only do when both numerator and denominator have some common factor. However, multiplication we can do with any of the number. Okay. What kind of questions we can get on equivalent fraction? The first type of question that we may get is to find equivalent fractions. Right, so we will be given a fraction, say for example 1 upon 2, and we will be asked to find say n number of equivalent fractions. Say the question asks find 5 equivalent fractions. Okay, what is the process? The process is to multiply the numerator and denominator by the same number. So we keep multiplying it. So to find the first equivalent fraction, we multiply both of them by 2. So if I multiply 1 by 2 and 2 by 2, so 1 by 2 gives us 2 and 2 by 2 gives us 4. To find the next equivalent fraction, I'll multiply both of them by 3. So 1 multiplied by 3 gives me 3, 2 multiplied by 3 gives me 6. To find the third, I'll multiply it with 4. So 1 multiplied by 4 is 4, 2 multiplied by 4 is 8. And the fifth one will be 1 multiplied by 5 is 5 and 2 multiplied by 5 is 10. So this is the fourth one. Fifth one will be multiplied by 6. Okay. Note that if I just multiply both of them with 1, it is not an equivalent fraction, it is an equal fraction. Right, equivalent fraction, again the definition is two fractions that have different numerator and denominator but they represent the same value. So that is why if I don't have to multiply this with 1 to get an equivalent fraction, I'll always start with 2. Okay, let us now look at it as an example. So find 5 equivalent fractions of 2 upon 3. So 2 upon 3 is the number. We need to find 5 equivalent fractions. So what we'll do, to find the first equivalent fraction, we multiply both of them by 2. Right, so if I multiply both numerator and denominator by 2, I'll get 2 2s are 4 and 3 2s are 6. To find the second one, I'll multiply both of them by 3. So 2 3s are 6 and 3 3s are 9. To find the fourth, I'll get 2 4s are 8 and 3 4s are 12. So 8 upon 12. So this is the third. To find the fourth, I'll have to multiply both of them by 5. So 2 times 5 and 3 times 5. So 10 upon 15. And with 6, I'll get 2 6 are 12 and 3 6 are 18. So this is the result that we get. So these are the 5 equivalent fractions. So it is not necessary that you have to divide in order. You can also multiply it with 10. You can also multiply it with 20, 30, whatever number you want. But you need to ensure that you are multiplying the numerator and denominator by the same number. Okay. Another example, we are given 3 upon 5 as a fraction. We need to find 5 equivalent fractions of 3 upon 5. Again, we multiply both numerator and denominator by 2, 3, 4, 5 and 6 respectively. So we'll get 6 upon 10 if you multiply by 2, 9 upon 15 by 3, 12 upon 20 by 4, 15 upon 25 with 5 and 18 upon 30 if I multiply by 6, both numerator and denominator. Okay, try to solve this question on your own. This is going to be easy because we have already discussed how to find equivalent fractions. We need to find 5 equivalent fractions of 4 upon 7. So the same process you have to apply. Right, so try solving this on your own. And we move on to the next type of question that we can get. So the next type of question you may get is, we may be given two fractions. We have to identify whether they are equivalent or not. See, here I am given, so before this, let me just give you a simple example. Say if you have 1 upon 2 and 2 upon 5. The question is asking whether these are equivalent or not. Okay. What you should do is, first of all, check if you'll be able to match the numerator or the denominator by multiplying it with some number. So first of all, identify the smaller number. So this one has smaller numerator and denominator both. So you have to multiply this with some number. Right? So try to identify a number that you should multiply either the numerator or the denominator so that you get this thing. Right? So if I multiply this with 2, I can see that I'll get 2. Right? So 1 multiplied by 2 gives me 2. So similarly, I'll multiply 2 with 2 as well. Let me just write this here so that the question remains apart from the answer. So 1 multiplied by 2 and then 2 multiplied by 2. Right? So 1 multiplied by 2 is 2 and 2 multiplied by 2 is 4. So I'm getting 2 upon 4. But this said that I should get 2 upon 5 because the question is asking whether this is equivalent or not. If it was equivalent, if I multiply the numerator by 2 and if I multiply the numerator by 2, denominator by 2, I should have ended up in 2 upon 5 if this was equivalent. Since I did not end up on the same number, that means they are not equivalent. Okay, another example, we can see 2 upon 3 and then 6 upon 9. We need to check whether they are equivalent or not. Again, we try to find a number by which I should multiply the numerator or the denominator. So 2 and 6. So if I multiply 2 with 3, I'll get 6. So I try to multiply both the numerator and denominator by 3. So 2 times 3 and 3 times 3. Okay, so if I multiply this with 3, I'll get 6 in the numerator and 9 in the denominator. So 6 by 9 and 6 by 9, they are the same, which means these two are equivalent fractions. So what we are doing is we are trying to multiply it with some number and then checking whether I end up in the same fraction. If I end up, then they are equivalent. If I don't end up, then they are not equivalent. Okay. Sometimes, so it is not always necessary that you should always check the numerator. Sometimes numerator may not be getting this number may not be divisible by the numerator, so you have to check for the denominator. Okay, for example, again 2 upon 5 and 7 upon 25. If this is the question, you can see you cannot divide the numerator. So when you are not able to divide something, that gives you a hint that it may not be equivalent. Right, so at that point you can confirm these are not equivalent. So when you either divide the numerator or denominator and it is not getting divided, or if you are not getting 0 as the remainder, then it confirms that they are not equivalent. Okay, so what you can do is you can just check if this is divisible. So this is not divisible, so you check if the denominator is divisible. So if I multiply 5 with 5, I'll get 25, right? So I'll also multiply this with the numerator. So 2 times 5 and 5 times 5. So 2 times 5 is 10 and 5 times 5 is 25. Are they both the same? They are not the same. So since they are not the same, they are not equivalent fraction. Okay. Another extension to this is we may be given shaded figure. So first step is to find the fraction from the shaded figure. So this represents 5 equal parts. So the denominator is 5 and out of that 5, 2 is shaded. So numerator is 2. So the question is asking, is 2 upon 5 and 6 upon 12 equivalent fraction? So what you can do, you can try to find a number. So first of all, you can just get a direct hint that this is not equivalent, because if you divide 6 by 2, right, 0 is the remainder, but if you divide 12 by 5, 0 is not the remainder. So to be equivalent, the numerator, if you divide the numerators, it should give 0 remainder. If you divide the denominator, it should give 0 remainder. Right? So if it is not giving that, then that gives you a hint that they are not equivalent. So 2 upon 5 and 6 upon 12. Try finding a number that you should multiply 2 with so that you get 6. It is 3. Right? So you'll multiply the numerator by 3 and you'll multiply the denominator by 3. If you multiply the numerator by 3, you get 6. So this matches this numerator. And if you multiply the denominator by 3, you get 12. 15. Right? 5 3s are 15, which does not match the denominator. So now these two fractions are not the same. So they are not equivalent. Right? Similarly, for the second fraction, it says, is this fraction and 18 upon 42 equivalent? How many equal parts are there? 1, 2, we can start with here. 1, 2, 3, 4, 5, 6, 7. 7 equal parts, which is the denominator. Number of parts that are shaded is 1, 2, 3. Right, now, what should I multiply 3 with so that I get 18? It is 6. Because 3 6 are 18. So I'll multiply this with 6 and multiply this with 6. So 3 6 are 18 and 7 6 are 42. Right? So I'll get 18 upon 42, which is the same as this number, which means that these two are equivalent. Right? The third question says this fraction and 25 upon 30. Again, total number of parts are 1, 2, 3, 4, 5, 6. Denominator is 6. Numerator is 5 because 5 parts are shaded. What should I multiply 5 with to get 25? It is 5. So 5 times 5 and then 6 times 5. Because I multiplied the numerator by 5, I should also multiply the denominator by 5. So 5 5s are 25 and 6 5s are 30. So I'm getting the same number as this. So that means these are equivalent. So what we were doing in the previous question is we are just trying to read out the tables of both the numerator and denominator by multiplying it with 1, 2, 3 and so on. Here we are doing the opposite. We are trying to see if I write the table whether I end up on this number or not. If I end up, which means if this number is equal to this, then these are equivalent. If I don't end up, for example, like this, so then the numbers are not equivalent. Okay. So what is the tip? Think of a number that you can multiply to both the numerator and denominator of the first fraction, which is usually smaller. So of the smaller fraction, we need to think of a number that I should multiply so that I am able to match the numerator or the denominator of the second number, which is larger. If the resulting fraction matches the second fraction, so if I'm multiplying this, if I get a fraction that matches this fraction, then the fractions are equivalent. If it does not matches, then the fractions are not equivalent. Okay. Since now we know what equivalent fractions are, this is going to be very quick and very easy. Simplifying fractions. So if you remember, when we are studying equivalent fractions, so there was a case wherein we want to divide, right, both numerator and denominator by the same number, like this. Right, so this is also known as simplifying. Why simplifying? Because these were usually larger numbers. The number that I start with is when we are dividing is usually large. So if I divide this, I end up in smaller numbers. So when we are converting larger to smaller, when you are reducing that number, right? So reduction basically means we are trying to simplify it. If you look into this figure, it will be more clear. So here, if you look at this figure, it is 6 upon 12. The figure looks quite cluttered, right? Now, by simplifying, what I mean, I remove the unnecessary lines. These are. Right, so once I remove these unnecessary lines, I'm left with a clean shape. Right, so this meant that 6 out of 12 parts are shaded. Now I cleaned it, so it became 1 out of 2 parts are shaded. So before simplifying, I had this cluttered form. After simplifying, I had this simple form. So that is why we call this as simplifying fractions. So what we basically did, we divided it by some number. Again, dividing means these two must have something in common. Both of them had 6 in common. So I divided both the numerator by 6 and the denominator by 6. right? So 6 divided by 6 gave me 1, 12 divided by 6 gave me 2. So what does simplifying mean? By simplifying, we mean that we are making the number smaller, but the value stays the same. These two are equivalent fractions as well. If you compare these two, you see that the value is not changing, right? So what is the difference between equivalent fraction and simplifying fraction? Equivalent fractions are the fraction that we can get by either multiplying the fraction or by dividing the fraction. Simplifying fraction means to find an equivalent fraction by dividing, right? So we have to divide only. We don't have any option to multiply. We just have to divide it because we want to have a simple fraction. We don't want to have a complicated fraction that has numbers in common. So we just want to remove something that is common between the numerator and denominator so that we end up in a very simple fraction, which shows the same amount. Okay, but the question is, how do we find the number that I should divide? Right, so this is a common factor between these two. Right, whenever want to find the common factor, see, 3 was also a common factor between these two. 2 was also a common factor between these two. But we choose 6. Why? Because this is the highest common factor. If I divide it by 6 once, I don't have to divide it by any other number. Otherwise, if I divided both by 2, okay, I would have ended up in, so 6 divided by 2 is 3 and 12 divided by 2 is 6. Still they have something in common. So I'll have to repeatedly divide. But if I find the highest common factor, I'll have to divide only once. There will be no repeated division. So that is why we find the highest common factor. Right, so using highest common factor, we can find the number that we should divide this numerator and denominator. Okay, so again, taking this example, 6 upon 12. First thing we notice that they have something in common. Okay, so we first find out what is common between these two numbers. To find that, we calculate the HCF. Here we are using the listing method. So 6, the factors are, we can write the factor pairs, 1 multiplied by 6, 2 multiplied by 3. These are the only factor pairs. So 1, 2, 3 and 6 are the factors. Similarly, 12, we can write 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4, and then 4 multiplied by 3 is again the same. So we stop. So 1, 2, 3, 4, 6, 12. So these are the factors of 12. Out of this, what is the highest common factor? It is 6. Right, so HCF is 6. So we now know that we have to divide both of them by 6. So I divide the numerator by 6, so I get 1. I divide the denominator by 6, I get 2. So the resulting fraction is 1 upon 2. Right, so this we call as the simplest form of a fraction. What does simplest form of a fraction mean? If you calculate their HCF, it will always come out to be 1. So when two fractions have nothing in common, it is known as the simplest form. A fraction in its simplest form. 2 upon 3. There is nothing in common other than 1. No factor in common. So it is a fraction in its simplest form. We cannot simplify it further. Right? How does it look visually? So here 6 upon 12 looked like this. We have so many divisions. 1 upon 2 looks like this. But the value is the same. The amount that I'll get here and the amount that I'll get here is the same. So they are also equivalent fraction. Okay. Again, we have these examples, say 9 upon 15. First thing we notice that there is something common between these two. So we find the HCF. So when there is something in common, we have to simplify. Right, so we have to simplify it to its simplest form, such that there is nothing in common between the numerator and denominator. No factor in common. So if try to find out the HCF. So again, 9, the factors are 1, 3 and 9. 15, the factors are 1, 3, 5 and 15. So the highest common factor that is common between them is 3. So we divide the numerator by 3 and we divide the denominator by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. Right? So the answer is 3 upon 5. Similarly, if I have 12 upon 8, right? Again, there is something in common because both of them are even numbers. So first thing is 2 must be common We can check by calculating the HCF if there is something else common. So we'll find the HCF of 12 and 8 first. 18. Factors are 1, 2, 3, 4, 6, 12, which we can find by listing method. 18 is 1, 2, 3, 6, 9, 18. So out of this, what is the highest common factor? It is 6. Right, so HCF is 6. So we divide. So I've already done a detailed video on HCF and LCM. So if you don't know how to compute HCF and LCM of two numbers, so you can just go to that video and then come back to this topic. Okay, so once we know the HCF, we need to divide both numerator and denominator by the HCF. So 12 divided by 6 is 2, 18 divided by 6 is 3. So we get the answer as 2 upon 3. Right, so the fraction in its simplest form is 3 upon 5 and the fraction in its simplest form is 2 upon 3. If you check, there is nothing in common between these two. So we cannot simplify it further. Okay. So this was everything that we need to know about equivalent fractions and simplifying fractions. But this is, although a very small topic, but it is very, very important. Right, from your school exam perspective, from the Olympiad exam perspective, both of them. Right, and it is very important to be conceptually strong in this topic. Try to understand everything using shapes, right? Shaded figures. So that will help you very much when you are trying to understand any topic related to fractions. Okay. So in the next class, what we'll do, we'll see how do we compare two fractions and how do we apply the concept of equivalent fractions. How does it help when we are comparing two fractions? Okay, so that is all that we have to discuss on this topic for today.